Yeah, wow.
Has it really been 3 years since this started? It feels like less than 10 minutes ago that we were sat here at the same time watching Vinay and Ben talk, and yeah, it's an honour to be here yet again. So as Ben was saying, I'm James, recently joined the ECG team, so I get to take a look inside of the mothership, and I dub myself officially allowed to hack the core, so that's my one aim. But you can find me on Twitter at Cowie, on GitHub, and me and Alan McGregor have promised one day to start Magecasts back up again. And what am I going to talk about today? So I want to give you a bit of a background on OOP, an insight into my thinking and how I actually write code and try and test code, a bit of my workflow, and if anything, a bit of a laugh for 30 minutes. So it was quite interesting recently that, I do a lot of reading. I've got the kiddies at home, and when they're asleep, I like to read a lot. And I actually started to reflect a little bit on what OOP actually means. Because we know what we're all taught at universities and schools, and when we actually start developing our applications, do we adhere to the best principles? Do we know what solid, dry, all these acronyms actually stand for, and how do we apply them to our code? Should we be applying them to our code? Should we actually be making our code testable? Is it worth it? Is what we're doing, is this code actually testable? Do we need to make it testable? So I want to go through a little bit of object-oriented programming. And Vinay, the pain, stole one of my slides. So I'm going to do a little bit of a pop quiz to see if anyone can remember this guy from earlier. So not only did he invent Smalltalk, he's actually been one of the founding fathers of object-oriented programming. Before him, it didn't exist, and it was a concept that he came up with. And what I found interesting was that we know that we should be doing OOP. We know that it's a principle that we should be following. But I always struggled to understand, like, what was it actually built for? Why did we want to do OOP over procedural programming? And Alan decided that the core principle of OOP was actually about messaging, communication between objects. And it started to think about how objects should talk to each other, like how should A and B actually communicate. And it sort of got me thinking about all the methods and the classes that I've created that don't return anything, that don't respond to the message. And it was interesting to look at the code, maybe through the eyes of 20 years ago, of how these guys envisioned OOP. And is the code that I'm writing what they would have been proud of? Is it what they thought about at the time? Am I just doing my own crazy little version of OOP and not really adhering to any standards and going off on a bit of a tangent? And when you think about, like, principles of good software, good object-oriented design, analysis, test-driven development, there's so many books that you can read. That was just the first page of Google. Probably all of these are out of date, and all of them precede me by at least 10 years. But they're still really valuable for what we need to do. And have all got little pieces and nuggets of information in there that we can adapt from, learn, and implement inside of our Magento 2 projects, Magento 1, Symfony, Laravel, whatever it is that we're working on. We can reflect on these principles and take them on board a little bit. So I'm going to go through a little bit of the boring stuff to start with, which is what Uncle Bob coined as the solid principles. Some of which I can't pronounce, the Liskov, so we'll skip that one. But I want to go through the solid principles that I find useful in my day-to-day job, what I actually use, what I reflected upon, and what I thought maybe is good to share with you guys. So the first one was the single responsibility principle. And this was really interesting. So the definition is that a class should have one and only one reason to change, meaning that it should have only one job to do. So I looked at one of the classes that I wrote and quickly took it off GitHub. But it was a class that dealt with RSS generation and Google product feed generation. So I took the single responsibility principle to heart and thought, right, this class is doing writing. So we're going to write a class. It's doing XML. So, right, we'll have an XML class. It's reading products. We'll have a reading class. It's like, right, they're all actually doing one thing and one thing well. But then when I read through what the single responsibility is, it's about having one reason to change. So not doing one thing well, but having one reason to change. So instead of having a reader, a writer, a job queue, a caching queue, all these different classes that I actually extracted out, it was maybe I can have this single class, which is the Google product feed, but then when it needs to be an XML feed or a JSON feed, then I can extract that logic out and move it into its individual places. And that was quite interesting because it meant that I had smaller classes thrown around the library, and it became a little bit easier for me to understand useful tests. I had what's coined as value objects for data translators or data mappers. The tests were quite pointless, and it was a waste of running PHP unit or bhat over the test. So by thinking about this responsibility of what a class actually has to do, it allowed me to think more about, should I actually be testing this? Is it valuable to me? How can I start to refactor this out and separate it out into different parts of an application? And then the open-close principle. This was another one that I actually found quite interesting, and I actually got it wrong quite a lot of times in my development, but it means that the class should be extensible without having to actually hack the core, as Ben had shouted at us all before. And I had a look through Magento 2 to see how is open-closed actually used inside of Magento 2. Is it actually used? And the good news is that it is. So Magento uses interfaces. Product interface, repository interface defines a service contract for what Magento thinks this class should do. And by using dependency injection and the preference XML tag, it means that we can say, right, instead of me having to modify the core repository class just to add get barcode instead of get SKU, I can add my preference and rewrite the class so it's open for extension but closed for modification. And then I looked at the interface segregation principle, which says a client should never be forced to implement an interface that it doesn't use, or clients shouldn't be forced to depend on methods that they don't use. And this one, I violated a great deal. I looked again at a few of the earlier classes that I wrote, where I knew that I had to use an interface, so I built an interface for a class, but it contained everything. It was not only get product feed, but it was get price, get the weather on this date. I think at one point it was even checking to see if I had an event on the next day. So I threw everything into these interfaces without actually understanding what the usage of this class was going to be and whether the interface was useful, because the more I got into using interfaces to be able to mock and use in the core of the application, it then made me think about whether they were actually useful or not. And then finally, like the dependency inversion principle, which states that entities must depend on the abstractions and not concrete implementations. So again, looked inside of Magento 2's core to see if this happened. And the great news, again, it does. Again, we've got interfaces, so we're not having to actually depend on a concrete implementation anymore. We've got the di.xml, which actually says anytime that you see the word interface, replace it with a concrete implementation. And that's how we should be developing in our modules. Anytime that we build a Magento 2 module or a PHP application for that point of view, we should be creating interfaces that we can rely on inside of our tests as well to make sure that we can swap out all the behavior that's needed, and then we can allow our client to implement the concrete implementation at runtime. So that gets the boring theoretical side of things out, and a little bit of the background of the research that I did coming into this. And I want to just give a little bit of a disclaimer that I do love Magento. What I'm going to say next is probably a little bit controversial, but I believe that a framework is just one of the tools that helps us develop better and faster, and that's from the Symfony documentation. So by using a framework, it falls into two categories when we're building our applications. We've got convenient code and we've got maintainable code. And by using a framework, it allows us to build faster. But that falls into the realm of convenience. So if we think about convenient code, we're talking about our code being quite coupled to the framework, it having mixed responsibilities. So we've got a model or a block that's merging, getting data, setting data, aggregating data, and pushing data, messaging it forward to other classes. It's very bound to the framework. We couldn't take our class or library and move it into another application. And it's quite normal that we find it hard to test. If we've got a block or a controller that's really coupled to the framework, whether it is Magento 2 or Symfony, it's hard to test because of the amount of dependencies that we're mocking. Whereas on the flip side, if we look at maintainable code, we say that it's decoupled. We can actually take it and put it into different places. It's separated domains. So if we think about domain-driven design, we talk about our bounded context and our domain objects. And we actually can think about that in our maintainable decoupled code as being representations of business logic. It's framework agnostic, so it is PHP code that doesn't really depend on anything. It doesn't know about a repository interface from the product collection. It just knows that it gets something, and that something is what it has to act upon. And we find that it's easier to test because it's not got any dependencies that we're having to mock. It's easy for us, because we own that code, just to do with it, test-wise, what we want to do. And Magento is, by nature, convenient for us to use. In one of our, that's a controller, an index controller, we can see that it's got all the helper methods for initializing categories, it's got the catalog design, so it's got all these helper methods that we can use by default to make a page, to show how products should look, to actually pull in the templates. So it's convenient for us to be able to build applications fast. And all that comes from just extending from the action, the controller action. We inject into it a results factory, into our constructor. So we've got a little bit of bootstrapping that we need to do to get this convenience, just to build our index controller. But what we actually get from that is a ginormous number of dependencies. So this was just the first few that I could actually copy and paste. So we've got a context which has to be brought in, a page factory, the registry so that we can load the current category, store manager, and the category repository interface. So they're all dependencies that this one index action has to actually deal with in order for us to build a page. And that makes unit testing incredibly hard, especially if you're new to developing and you've gone down the convenient route. You realize that you should be unit testing now, but you then have to start understanding how to use mocks, whether you should be using a mock or a double, how PHP unit works, how mockery works, what are the dependencies of our dependencies, and before you know it, we don't really want to unit test anymore because it's fighting us, it's giving us a barrier to learn. And we tend to see that convenient controllers or convenient code requires more integration testing because we can see that writing unit tests is hard. We go down the easier route of using Selenium, Behat, Mink, Go, all the drivers that allow us to do integration testing. So we're actually testing browser user behavior going through the site. And if we look at a project that sees we've got a lot of integration tests and maybe not so many unit tests, it's a smell that maybe we should look at how we can refactor our domain, our code. Can we start to refactor out so that we can get more unit tests, go lower level and move stuff out? So let's take a little look at an example. So the example that we're going to build together is a Google product feed. It's the easiest one that I could come up with. And we're going to start off just by using the default Magento command object, which is going to build our command, our product feed. So we configure it by setting name, setting description. And our first pass allows us to implement the execute method. So what we're doing here is we're calling the product repository to get us a single SKU because it's a Google special product feed that just does an individual showcase. It calls the file system writer. So we're using convenience here. We're not actually implementing any of our own writer objects or handling anything ourselves. We're using the convenience from the framework. So we're using the open file methods, we're locking the file, we're using JSON encode, and we're spitting the file out. But now we want to add XML generation to our class. The project's evolved a little bit, so our little proof of concept or our startup has evolved past what it used to be. So we could go down the route of just adding it to our class. Our execute method has now got an XML feed in there. But that's a little bit of a violation of our single responsibility principle, because our class has had a reason to change. No longer was it just having to do JSON, doing JSON well. Its behavior now had to evolve into understanding how to deal with XML generation. So it is still doing product feed, but it's doing two parts of a product feed. And actually, how do we go about testing that? Because we've got this big execute method now that was sort of manageable when it was just doing JSON, but now it's growing into quite a complex application that's dealing with XML generation. And if you look at the list of dependencies that we're actually pulling in, not only are we pulling in the product repository, thankfully we're using the interface so it's easier for us to mock it out, but we're calling in the application state, we're pulling in the file system object, and we're actually calling in the simple XML by instantiating a new object of it. So we've got there 4 dependencies that we actually have to go away, think about, and mock ourselves. So I'm going to go the easy route. Instead of using PHP unit or PHP spec, what I found easier, especially when I was entering the realm of testing, was to look at bhat as a tool of defining testable behavior by creating user-given scenarios. So it uses a framework or a language specification called Gherkin, which we write scenarios in human-readable format. So we give our scenario, which is that products are represented in a JSON file. Our given is what we set the scene with. So we're saying, given the generate command exists, when is what we're actually doing. So we're actually like trying to force something, it's our action. So when I run the generate command, we've then got the then I should see a JSON file is created. And then is our assertion. So we've got a given, which sets the scene. We've got the when, which is our action, our doing word, and the then, which is the assertion of the test, the scenario that we're wanting to test. And by running bhat in it, we get a feature context file. And all we really need to do there is make sure we use the context. We're going to pull in a library from the Symfony framework called process, which is going to allow us to execute PHP processes via our PHP script. And we're going to pull in the Symfony file system just for convenience. So our feature context has to implement the context. And inside of our constructor, we're just going to create a variable of output, a variable of file system, and we're going to construct the new file system object just for use inside of our testing feature context file. And how bhat works is it uses reflection to have a look at the annotations of each of our methods. So inside of our feature file, the given when then actually maps to the feature context file using the annotation that we can see for each of the methods. And then the method gets executed. So here for the generate command exists, instead of actually checking that the command exists, we're pretty confident in using Magento's framework to implement our argument. So we're just going to return true cheekily. Whereas in the when, so again it's read the annotation, we're running the command now, we're going to call the Symfony process, we're going to actually invoke the bin Magento command with our generate showcase product feed, we're going to run it, so the process actually runs the PHP thread, and then we're going to capture the output in our variable. So we've actually executed something now, we've got that output of the process in memory, and we can start using our assertion on it. So we can use the expect library. You could use PHP's assert true or assertion libraries. But what we're saying here is that we expect that the file should exist. So given when then, we've now actually got our first integration test, which is making sure that our generator works. We know that by running this, we should have a file created because we wrote the code in the first place. Maybe it's been in production for some time. And funnily enough, our test actually passes. When we run bhat on the command line, you can see that it ran through each one of those steps, and we've got a passing scenario. Our file existed on the disk. But because we wanted to consider how XML could be generated, we write another scenario. So this time that the products are represented in XML format. So we're given that the generate command exists again. When we run the command, this time we should see that an XML file is generated. We run bhat. Funnily enough, our test fails because it isn't generating XML. Our assertion step is making sure that a CSV file exists, whereas actually we're wanting to see if an XML file's there. But bhat tells us that we need to implement that step. So it gives us a pending definition, which is what the orange stands for.
Now what we could do here is just add the XML generation like I showed you before into the onExecute method. We'd run bhat again, and all of a sudden we get a load of green passing tests. But it breaks the open-close principle in a degree, and we're actually not making our project more maintainable. We're going for convenience and over convention. So let's start by going down the Magento 2 route and adhere to open-close principle by initially creating a builder interface. So we know that we're going to have to build JSON and we're going to have to build XML. So inside of our API directory, we're going to create a builder interface. So the namespace is Titans Showcase API. And we know that when we want to build a file, whether it be XML or JSON, we just want to have a build method that gets data passed into it. We want to now actually capture this new feature that we're building, because we're refactoring out. We need to make sure that we've got a scenario to cover ourselves. So where previously we were actually testing user behavior, we were going away and actually testing the PHP processes if somebody was simulating sitting at a keyboard typing bin PHP Magento, checking that the command was there, just like we would do if a user was going to go to a browser using the Mink driver. This time, we're actually worrying about our low-level implementation. So we're using bhat in a way that it's similar to unit testing, but using scenario-driven or BDD-driven design. So this time, our scenario is that the class does return JSON. So we've taken it a layer down our domain stack. And when I call a JSON builder class, then we should see that JSON is returned. So inside of our feature context this time, what we want to do is actually pass in our builder, our JSON builder. Because it's a value object or a data mapper, we don't need to worry about using the interface because we want to make sure that it's JSON. We're actually testing that class, not the interface and the theory behind it. We're actually testing the implementation itself. Again, the annotations get mapped to each of the methods. So this time, what we want to do is call the build method. If you remember inside of the JSON builder, we had the build method. This time we say that it should return the JSON correctly. And in the assertion step, we just expect that it should be the same as a JSON encoded PHP array. If we run our PHP unit, our bhat there, we could see that it actually failed. So we implement our class, which implements the interface. It does a quick JSON encode. And the keeping principle there is that we're actually implementing our interface so that if we did want to test further up the line inside of our command class itself, because we're passing in interfaces and using dependency injection, we've got the ability to know what our classes should do without having to rely on the low-level implementation. So there we've got our JSON builder implementation. And we've also got our XML builder implementation. Both implement the interface and both implement a build method. If we go inside of our command class itself again, instead of having to deal with how the actual node or data structures got built, we can pass into the constructor, the JSON builder. We could even, if we were going to use a factory method, pass in the factory and implement the generation that way. But because at the moment we're just interested in JSON, we'll pass in the object directly, assign it to our variable, and then inside of the writer class where we execute the command, we can just call our writer and it builds the JSON as we'd expect. By running bhat, both of our scenarios could now theoretically pass because we've built and refactored out into individual objects. Instead of having this one monolithic command class which did both XML and JSON potentially, we've now split it out into being a command class that does commands well, and we've got a JSON and an XML class that do XML and JSON well. So their responsibilities are quite clear. And if we look at how Alan Kay actually spoke about messaging in the first place, we can see that our command class sends a message to the builder class, which is the data. The command class is responsible for handling the command itself, whereas the JSON builder class is responsible for building JSON based on the message that it was given. It's acting upon the message, and we can treat it as sort of a value object. We pass data in, we get data back out. It's not doing any business logic. It's not affecting the state other than transforming it from one format to another format. And if we look at how we're actually going to test these in the real world, we can see that in our command class, because it's very framework coupled, we're using the convenience of the framework command helper. We're going to use integration tests. Whereas for our builder classes, it's a library code. It's supplementing the class itself, the command. We're writing PHP individual implementation code. It doesn't know about Magento there. It's getting passed in an array of product data. So we can use unit tests and we can separate that out to being more of a library code that we could use on other projects. Easier to test, easier to unit test, and then we can replace the interfaces or the implementation inside of the command class at runtime. Now, it was a bit of a whistle-stop tour of showing how Bhat can actually help us get into testing as more of a stepping stone into how we can use Bhat as a way to test our framework, as well as testing our lower level implementation. But some of the benefits of doing this is that we can see how that we're now passing messages between our code. If we wanted to debug why there was a problem with our JSON implementation or the XML implementation, instead of worrying about how the data is built, we can look at the concrete implementations to see, is anything being done to it? Is a manipulation being taken place? We can see that we're actually testing using Bhat on many different levels. So when I first started using Bhat, I instinctively thought of it as being a Selenium style implementation of just testing user and browser behavior. Whereas you can see there that we're actually testing low level implementation. We're using it as a semi PHP unit style implementation. We've got clear objects and definitions, roles and responsibilities of each of the objects, and we're starting to use value objects more. We can actually implement an object that doesn't really affect the state, it just transforms data from one way to another, and they're cheap and we can throw them away or just use them directly in code. So I hope that you did enjoy the 30 minutes whistle-stop tour of how Bhat actually works, and a little bit of a crazy insight into my mind and how I work. Have we got any questions from anyone? Good, let's go and get some food because I'm starving.